Are you working? Cool. All right. Codeforces around 766. Let's go. In one operation, you can select some black cell and do exactly one of the following. You can either color all cells in its row black or color all cells in the column black. Okay, so we just do some casework here. It's only impossible if there isn't a white, if there's all white cells. So NMRC. MRC. Okay, so this is black. Yeah, that's problem A. Problem B. Oh, okay, so Rahul wants to sit close to Tina as possible, but he refuses to sit anywhere that's been colored pink. Okay, this is probably important, the fact that they multiplied 10 to the 5. And so Tina can sit anywhere that's painted or not painted. I think Tina always goes to a corner. Right? Yeah. He always goes to a corner. Yeah, the more bucket of paint, more paint buckets. Yeah, so if we don't paint like a middle cell, then our whole will just take it. And it doesn't help us. So I think we can use like priority queue of some sort. Yeah, where it's like the maximum distance. We want to make sure. No, we want to sort it by minimum. Yeah, because Rahul wants to minimize. And Tina wants to. Okay, so it's like we order by maximum distance. We go by the smallest. We use a priority queue to like just take care of that. So let's try that. So it's a maximum of, let's do 0 indexed seats. In which case it's just x dot r. N minus x dot r minus 1. Then why is x dot r not working? Oh. Seat. Okay, there we go. Plus max of x dot c. And then if you're at the bottom, or if you're at the very last column, then it's like m minus x dot c minus 1. Yeah. And max 2 is equal to same thing, except instead of x, it's y. I want to make sure to sort this by, well, okay, the maximum seating arrangement. Yeah, so we want to get rid of the one with the minimum maximum first. Yeah. New CRC. Wait, so what is? Okay, the distance for each k equals 0. the hole chooses to sit here, and this is the best distance that we can get. Expected 3, found 5. Okay, so if we have 0 choices of paint, then wait, that's not right. Huh. I'm so confused. Oh! That was pretty stupid. Okay, that looks right. Okay, that was a silly implementation mistake. You're given a tree of n vertices number from 1 to n, and edges number from 1 to n minus 1. Okay, so just a tree. A prime tree is a tree where the weight of every path consists of either one or... Wait, where the weight of every path consisting of 1 or 2 edges is prime. The weight of every path, 1 or 2 edges. Okay. Print any valid assignment of weight such that the resultant tree is a prime tree. Is it only possible if it's a line? Do edges have to be distinct? Yeah, okay, it doesn't have to be distinct. So we could use 2, 3, and 5. Okay, if we have an odd cycle, I think it's impossible if it's an odd cycle, because if we have 2 odd numbers, Odd numbers can't add to an even number, that's obvious. So it has to be 2 has to be on every other edge. That's the thing. 2 must be on every other edge. So we can just say it's 3 for the rest of them. And so if it's like 2, then this has to be 3. Then this can't be 2, but this can't be 3 either. Yeah, so it's only when it's an odd cycle. So we just check to see if it's by part type. And then otherwise we just assign to every other edge. So you read in a tree, right? Yeah. Okay. This is n. Assigned to edge I. Okay, so we need to store the edges themselves. Okay, so if we assign edges is this. Print n-1 lines, right? Yeah, because we just assign the edges. So in other words, for I equals 0. So what do we need to do? I mean, no, it is impossible if it's a line. If it's not a line. Because if any vertex has degree of that, then it's like it's either 2. Then it's either 2. It has to basically be an even and an odd number. And no matter the edge we add here, it's always going to force another even number that's greater than 2. And 1 is not prime, so we can never use 1 anyway. Because it's also 1 or 2 edges, yeah. So if it's not a line, then it doesn't work. Does the input match that? It does, yeah. Okay. I mean, an odd cycle won't exist in a tree anyway. but we could do so if edges at V dot size is greater than or equal to 3. So if edges at cur dot size is equal to 1, prev does not equal to -1, they break. Otherwise, prev is equal to 0. No, prev is equal to where edge E edges at cur. So if E dot 2 does not equal to prev, then prev becomes E dot, well, prev becomes cur becomes E dot 2, and then res at E dot ID is equal to weight. And then we break out of here. Line 39 has an error because I forgot to subtract by 1. Wow, I'm so good. Line 67 has an error. Because this has to be subtracted by 1. Wow, I'm so good. Line 73. Because it's a -1. Wow, I'm so good. Jesus Christ. Okay, we got it. Okay, let's move on to D, I guess, yeah. I had no... Okay, let's see. What was it? Okay, so we have an array consists of n distinct integers. We need to perform the following operation. Choose 2 elements such that GCD is not present in the array and add GCD to the end of the array. What is the maximum number of times we can do this operation? And all of these values are distinct. Okay, let's assume if A, B, C are prime numbers, A, B, B, C, C, D, GCD of B, C, and C, D is just equal to C. And then GCD of A, B, and C is equal to 1. Yeah, but that's not true. Not every pair. But if we did CA, GCD, this is also equal to CA. Okay. So in this case, all pairwise GCD is greater than 1. But GC, A, B, and C would be equal to 1. I think only the most common terms matter. Also, does order of operations matter? Maybe. Not sure. Yeah, because we just want to increase the size of this array. Let's say doing a GCD if this was equal to C, but if we GCD'd with another element, we could have gotten 2C. I mean, it doesn't. If we GCD to get a smaller element, the ability to GCD to get the element bigger than it won't be affected. But the thing is, getting a bigger element can potentially help us get smaller elements. Okay. So at every iteration, we just want to pick out the GCD. You can't factor every number. I could do prime factorization though. Maybe that will help. Okay, I think I know how to do this. Max plus 1, where we define C not V. think it's if ABC, ABC. Maybe we could take a GCD. Where it's like we try to put in this element. But even if they're like pairwise thing. Okay, yeah, we just have to check to see if GCD is 1. So, we can use int for this. I'll make it a little bit more faster. So int GCD is equal to 0. Then x is equal to the first multiple of v if we've seen x, then in x over v okay, we got D. Move on to problem E. Let's see. Okay, E is definitely the easier one. At least it seems like it. Also, sorry about the background noise. It's okay. Hopefully it won't be too much of a bother. But yeah. Not escaping. Major ram is being chased by his arch enemy at the top of the building. Ram must choose the optimal path to reach the top of the building and lose a minimum amount of health. Okay, so N floors each with M rooms. Okay. Let this represent the Jth room in the ith floor. Okay, so it like goes up like this. Or I guess like, yeah. The K ladder doesn't solve. So you can go up but not down. You also gain this much health if he uses a ladder. Okay, guarantees that we go up a row. Or go up a floor, yeah. If you're on the ith floor, he can move either left or right. Traveling oh, okay. What if he takes him with the optimal path? Oh, because ladders gain health. I think we're most interested in what the for each okay, and an M or 10 to the 5, so we can't represent the entire building. How many ladders? Up to 10 to the 5. I think what's important is how many ladders we use. Because, okay, if we assume there aren't any ladders, the most optimal path is to find the floor that has the least xi, go to that floor, then move all the way across. I think it's more important to consider what is the. I think it's best to consider what the. We want to try to get to a ladder with the minimum amount of health lost. I think that's important. And then we can go up a ladder, and then from there, it's just like. Thing is, it's 10 to the 5, so we could use something. If we use. I also think I want fast scanner for this. So. Okay, so there's almost one ladder between any two rooms in the building. Okay, yeah. Okay. So we can do like this minimum health. It's a health loss we go from to get to this spot, or DP or C -1 plus, or DP or C +1 plus XR. Ladder exists since it's DP at R at C. DP at plus minus health. Wait, he can only use ladders. Okay, so I might actually, I misread it, but that actually might make it easier. Because if he can't use ladders, then okay, well, that's the thing though. In the first floor, we can go anywhere we want, but we can only progress if there's a ladder up there. Yeah, that's what makes it easier if we're not allowed to jump up floors without ladders. Because then, any floor that's not the first floor, we can only start there if it's at the top of the ladder, and there's only at most 10 of the 5 like tops of ladders that can exist. So it's like for each, we can store like ladder events then. So it's like we start at the first floor. We figure out all ladders that we can reach. Get the minimum cost, and then we go up there, and then like that will guarantee the minimum cost of a top ladder because it's like first floor we can just go straight. And then from here we want to get the minimum distance from this ladder to all the ladder bases on that floor. Okay. Let me read in this input. Okay, so do we do arrayless or? Run a loop through all ladders and consider the active position. I guess we could do like prefix and suffix. Or it's like for a ladder. Yeah, we do like a 2-pointers thing. Yeah, we could do something like that. I think that would be smart. So if we do something like we maintain a list of if we do like 2-pointers. So it's like we can do, we need these to be in sorted order, but we can sort them once we get to the, yeah, because then, yeah, we can sort them when we get to that row. It goes up to n rows, and then K ladders, right? Yeah. Oh, right. Also, public in health. Wait, so what is it? ABCDH. BCDH. So ladders at A dot add new ladder goes BCDH. DP at 0 dot add new node where we're currently here. he loses this much health. Okay. Goes new node at 0. Yeah, because we haven't taken any damage yet. Okay, so for each row, there's no escape. Ladder D in ladders at row. So ladders that start here. Let's see. Nothing. What are the values? 5, 17, 8, 1. Okay, so to get the row 2, column 2. I guess it's 0, 1, 2, 0, 1, 2, 3, 4. To get the row 2, column 2, we need to go 12 minus 8. No, 12 minus. Statement. There are only 2 possible. You travel, so 3, 2 takes a travel. Yeah, 5 times 2, which is 10. Minus 4 is 6. It should be 6, okay. There should be 2 different DP spots. Yeah, we're missing one of them. Because the other possibility is 21. Oh! Pff, Jesus Christ. It's in it, Right, okay. I didn't update this cost correctly. It shouldn't be too hard. It's not too hard to fix, though. I don't think it is. How much time? Yeah, that's definitely enough time. Because prefix is equal to max. Or I guess min. Min. I think it's this. Okay, still not giving the right answer for the first one. Wait, but the idea is that in row 4 we should have 2 different DP values. If we iterated over this, then we may have forgotten to update the prefix value. Yeah, that's why. Okay. DP at D dot next. Okay, so if last position does not equal to -1, then we do this. D dot next D, the prefix. Yeah. -16, no escape, -90. Not prefix. It's dp. Cost. Tax. Prefix. Cost. I think that's better. Because yeah, we're gonna minimize this cost. Oh wait, is it possible for it to exceed a really big value? So we move up to 10 to the 5. So it's up to 10 to the negative 11. So it's about 10 to the negative 16 is like the worst. And I just like update it automatically. Yeah. Yeah, so that should be an okay infinite value. Yeah, or it's like it's better to do something from here. Suffix, suffix, suffix. Yeah, because we can just go to that ladder and then go up another ladder. If last position does not equal to -1, do something like let me just make sure that this is like actually working correctly and not just giving the right answer just because. Are duplicate dB values okay? I forgot to sort them! Oh god, I forgot to sort them. I forgot to sort them. Shit, I'm so dumb. Oh my god. I forgot to sort the frick. I forgot to sort ladders. Oh, I forgot to sort ladders as well. Oh my god. Bro, of course it doesn't work. Jesus Christ. Ah. Okay, so we need to sort the nodes first by increasing. Okay, so x dot call minus y dot call. Collections dot sort ladders at row. These need to be sorted by increasing column. So x dot cur c minus y dot cur c. Oh my god, I feel so dumb. Still wrong answer though. Does this need to be sorted? This part? No. Are we sorting it by the right thing? Yeah, we are. What if we had a 4x3? Cost of moving here is 5, and the cost of moving up here is 10. Well, we gain 10. Or we could go up one ladder, up another ladder, up another ladder, and then this is 1. And if all of these are 1, then it's like -1, -1, -1, 1, 1. It's like -3 plus 1 is -1. Okay. What is that supposed to be? Okay, so it's 4, 3, there's 4. It goes 5, 100, 101. Okay, so row 1, column 1 goes to row 2, column 1. Okay, so then it's like row 2, column 1 goes to row 3, column 1. Row 2, column 1 goes to row 3, column 1. So it's like row 3, column 1 goes to row 4, column 1 with 1. And last ladder is row 1, column 3 goes to row 3, column 3 with 10. So this should give -1. Okay. But if this was 4, then it should give a different value. The value it should give is 2, I think. Okay. Wait, yeah, if this was 4, then we could go 8. The answer should be -2 then. Okay. We can debug this. Okay, 0 column -3. Let me make sure these ladders are correct. Row 1 column. Oh, row 1 column 3 to row 4 column 3. Oopsies. Yeah, if it's row 3 column 3, it's obviously -1. But it's row 4 column 3 to give -2. Yeah. That's row 5. To give -1. If there's no dB values to the left or the right of it. New node. It ends up at next C. And the cost it takes to go up there is prefix, which is like the best prefix cost. Plus, well, not minus last position times cost of row. Wait, what if it was the same? It was like what the previous cost was and the new cost. Yeah, if it's better, then like, this is better. Last position. I have to make sure last position gets updated correctly. dp at row get cost. dp at row dot get dex, where dex is the rightmost, the one that's located at the rightmost. Suffix. Yeah. Because as dex decreases, this value decreases because we sorted dp row by column. Minus d dot health. Yeah. Yeah, and then it's just like, well, what whatever the best cost was, we add on this distance. So it's like long. Yeah. dp at d at next r. Wait. Okay, so if best is equal to infinity, well, best was equal to prefix. So it was if last position. But we wanna just, if we ignore this, that way we don't have like repeat values. Well, yeah, I think we literally just ignore that, because after this process ends, prefix will be the best possible value. But that shouldn't give a wrong answer though, right? It would have given TLE if that was a bug. Okay, well, let's check to see if this is still like, if this still makes sense. -4, and if this is 6, for example. I meant to say 4. I meant to change this to 6. There we go. But that shouldn't give wrong answer though, right? Does TLE? Or maybe? I don't know. Let me just get rid of it. Yeah. So I thought. Yeah, there are n rows, right? Yeah. We sort by this and we sort by this. Oh my god, I'm so dumb. Oh no! Collections are reverse, letters in a row. Oh my god. That has to be why. Wait, is that why? Wait, oh no. Oh my god, that was the reason why. That was a bug. That was such a stupid bug to get. I feel so bro. A stupid ass bug. I'm kind of mad at that. It was, I got the idea of this problem in like 10 minutes. And I spent like half an hour debugging. Ah! Bruh. Okay. Whatever. Good God. I might as well just read F. There's a K times K grid where K is even. wonder how much my rank went up by. Okay, it went up by about, I think it seems like about 100. So 5367, if I was official, 5367 points would be probably around here. Okay, no, here, 53. Okay, that would have been right around like 50-ish, 50-ish. I guess that's okay, but I should not have spent that long on E. I really should not have. Oh god. We're given a k by k grid. K is even. The square in row R in column C is denoted by this. Two squares R1, C1, R2, C2 are considered adjacent if R1 minus R2. Okay, yeah. An array of adjacent pairs is called strong if it is possible to cut the grid along grid lines into two connected congruent pieces so that each pair is part of the same piece. Array of adjacent pairs is called strong if it is possible to cut the grid along grid lines into two connected congruent pieces so that each pair is part of the same piece. Two pieces are congruent if one can match the other. Okay, I see. You're given an array A of n pairs of adjacent squares. Find the size of a largest strong subsequence of A. That seems really hard. Oh god, it's like geometry. Wait, that seems kind of hard. Oh no. To cut, and you can cut along any grid line. Oh god. I kind of just want to try hacking instead, honestly. Verdict. Is there any problem that's been hacked? Okay, 2 on A. Is my A okay? Okay, so if it equals this, then it's obviously 0. If it contains a B, then we know the result is at least 2. And if one of these is okay, then it's equal to 1. Yeah, okay, this looks okay. For any problem, hacked any language. B, I don't think would get hacked. C, no. D, I don't think so. E, probably not. Okay, maybe I just focus on like getting A hacks then. Honestly, it seems I just don't want to. Like, my brain is kind of fried from debugging. It's whatever. Okay, wait. Let me just do this so you can actually see what's going on. Let me dark mode. Turn off dark mode. Dark mode. Dark mode. Okay, that's good. If it's R and E equal to, okay, so if it's same, well, else if any. Okay, that's the same as my solution. Yeah. equal to 1. Inverse. Okay, so if this is equal to b, then 0, else if this or this, then it's equal to 1, else if 2. Yeah, seems legit. I feel like I should probably start working from bottom up. If this and this, then answer becomes 0. Answer is min of... Okay, yeah, seems legit. What could the hack? I feel like maybe just like stupid casework, although my entire room is like full of orange and reds. So I feel like just okay, wait, hold on. This looks a little Cancer. So Cancer to the point where I don't even want to try to hack that. Oh my god. Okay, so it's black. Okay, so if it's not Z, else if is equal to B, else if X. Oh wait, no, this is right. Okay, yeah. I think they just accidentally copy pasted twice or something. Okay, so have and print. Okay, you already did that. And then if it contains this, then print 2, otherwise -1. Yeah, I feel like people in here won't like make stupid mistakes. Yeah, because if this 0, if this 1, if it's 1, if it's this, then it's 2, otherwise -1. I'm just gonna try looking at people that I know. If not any -1, if this then 0, otherwise... Okay, if it's good, then print 1, otherwise 2. Yeah. I'll use Java. Nice. Okay, false. Okay, so black is 0, and B will be false if this then 0. Yeah, that looks fine. If not B, and return -1. If this is equal to B, this is equal to, yeah. Okay, honestly, I think I'm gonna just stop here. I'm not, F just seems hard, and I don't think I'll be able to get to hack anyone. So yeah, and I'm not really that interested in hacking either. So yeah, if you did this contest, I hope you did well. Yeah, let me just turn off dark mode, and I'm gonna eat because I haven't eaten anything today. I'm kind of hungry. But yeah, see ya. And if I'll try to see if I have time to talk about the first 5 problems. But yeah, aside from that, if I do, then I'll probably upload that either later today or tomorrow. But honestly, no guarantees. School's about to start really soon, and I also am busy with other stuff. So yeah, see you then.